Okay, so from within the unsaturated hydrocarbons, we have alkenes and alkynes. You will check the corresponding sections of your book. So alkenes are general formula CN H2N, because remember we have a deficit of hydrogen. In alkynes, we have an extra deficit of hydrogen, so the general formula is going to be CN2N minus 2H minus 2. So you're going to have less and less hydrogen as you increase the number of double bonds or triple bonds present in your molecule. When you're naming them, you're going to make sure that you get the root name first based on the number of consecutive carbon atoms, the longest consecutive carbon atom chain, and then you're going to add the suffix in or ein, depending if it's double or triple bond. So this is 1, 2, 3, 4, 5. So it's a pentyne. I need to include the position or where is the double bond located. I always have to give priority to the double bond. So I need to start numbering from left to right. So this is the 2-pentyne, or also you can find it in your book as pent2-ene. Oh, it's in. Pent-ene. Sorry, I had. So pent2-ene or 2-pentene. You see this molecule again, and it's again 2-pentene. These two molecules are isomers, okay? It's a special type of isomer. If you read or remember from last time, there's something called geometric isomers, or within the stereoisomers is going to be a type of isomer that has different structure because one of the bonds is restricted, okay? So sigma bonds are free rotation, pi bonds are restricted. So these cannot rotate to have conformers. So the way that I can tell them apart, because they have slightly different physical and chemical properties, it's going to be by including the term that we saw for cyclic isomers, the term either cis to include both substituents on the same side, this one and this one. I'm fixating on the ones that are similar. I need to imagine there's a plane going through the double bond, and you see both H's are on the same side. So that's the cis pent2-ene. In this case, I have the hydrogens on opposite sides of the imaginary plane. So I need to include the prefix trans. Trans 2-pentene or trans pent2-ene. Then we have the other case in which we see the substituents around the double bond. You see that each one of these substituents is different. So there's no way for me to say cis or trans. So that's why we include an extra term that is going to be based on priorities. Priorities are going to be assigned the same way that they were assigned for optical rotation, okay, based on atomic number. So carbon, this carbon on the left-hand side has a chlorine and a hydrogen. Based on the atomic number, chlorine has priority. This carbon atom, however, has 2 carbon atoms around it. Based on your knowledge from assigning priorities, you see what is attached to that carbon, okay? So this one only has hydrogens. This one has 2 hydrogens and an extra carbon. So this one has priority. This other isomer The chlorine was flipped over, so now it's here, priority 1. The ethyl group is here, so that's priority 1. When you want to include this type of isomerism in a double bond, you need to include the term based on the German word, because that's where this was studied for the first time. E is going to be included for the isomer with substituents in opposite sides, and it comes from the German word entgegen and gegen. And then you're gonna have the other option in which you have the higher priority substituents on the same side of the plane with zusammen. Zusammen, it's trying to tell you that they are on the same side. So E for opposite and Z for zusammen, for same. The way that this is going to be incorporated in the name is going to be just by including it at the beginning of the name. So this is the E1 chloro 2 methyl but 1 in, and this is going to be the Z1 chloro 2 methyl but 1 in, or butene 1 butene, whichever you see in your book. They are both accepted, but I think in your book this is the way that it's done. The 2 in between the root name and the suffix. So that's all for